Adhesive tape was invented in 1925 as a painter's masking tape for auto body shops. That led to transparent tape, designed to seal the cellophane wrap used by the food industry. Then tape was introduced as a household item, and the idea just stuck. These rolls of plastic film, called polypropylene, are on their way to becoming shipping tape. The rolls go on a machine called the unwinder. Workers then position a strip of adhesive splicing tape along the end of each roll. This will enable them to connect one roll after another, creating an uninterrupted feed to the production line. Now watch closely. Once a roll unwinds completely, its end sticks onto the splicing tape at the beginning of the next roll. Once that roll's unwound, its end will stick to the beginning of the next, and so on. An automatic tension adjuster ensures that the machine pulls the film evenly to prevent ripping. The unwinder also applies a solvent to the film surface. This prevents the film from sticking while unrolling. To transform this film into tape, they coat one side with a hot adhesive known as hot melt, made from several ingredients. Synthetic rubber gives it flexibility. A UV protector keeps it from drying and discoloring, while an antioxidant prevents aging. Synthetic resin makes it sticky, while pigmentation oil provides a choice of colors, in this case, tan. They load the hot melt into a preheated holding tank, which maintains it at a piping 200 degrees Celsius to keep it from hardening. The tank pumps the adhesive to a machine called the gluer. They wipe away the excess, then roll the film. And there goes the adhesive. A cooling roller, that black one on the top, immediately hardens it. A computerized sensor ensures there's an even coat of adhesive. If not, it automatically signals the pump to adjust the output. Now, a machine called the rewinder rolls the tape onto spools. Remember the unwinder that spliced the rolls together? Well, the rewinder unsplices them. When a spool fills, a knife separates the tape at the splice point so that winding can begin on the next spool. The tape on just one of these spools would run the length of 85 football fields. The spools feed a row of sharp razor blades called the slitters, which divide the 1.5 meter wide tape into several strips. Shipping tape is 48 millimeters wide, so they get 31 strips per spool. Each strip winds onto a cardboard core, its end sealed with a tab. The length of tape per roll varies according to the customer's specifications. As the machine ejects the finished tape rolls, in comes the next batch of cardboard cores. Then it's off to the packaging department. Nothing's shipped out, however, before a quality control check. They test a sample roll from each spool. In one test, they unroll the tape sticky side up, then release a tiny stainless steel ball down an incline, measuring how far the ball rolls before it sticks and comes to a stop. To pass the test, the ball has to adhere within a certain distance. The stopping distance varies depending on the type of adhesive tape. Around 1000 AD, craftsmen began making intricate window designs using lead rather than wood or plaster between pieces of colored glass. Before long, the church was commissioning stained glass windows depicting religious scenes to adorn the great cathedrals of Europe. You can make stained glass two ways. Using copper foil, a technique developed about 100 years ago by the American artist Louis Comfort Tiffany, or you can use the centuries-old European lead technique, which we're about to see. First, the artist lays a plate of glass over a pattern and traces the parts of the design that she'll cut from that plate. Then she scores her trace line using a glass cutter. A quick snap, and the glass separates neatly. She follows the same procedure with different colors and textures of glass for all the pieces of the design. By running the cutter slightly inside the trace line, she leaves room for the strip of lead that will later hold the pieces of glass together. Once she finishes cutting all the pieces, she checks them against the pattern, making sure they fit together properly. Now it's time to assemble the pieces using the pattern as a guide. This zinc molding will frame the panel, its inner groove fitting over the edge of the glass. The artist positions this molding along the perimeter of the pattern. Then she drills an L-shaped wood frame into the work table to hold everything in place during assembly. A few nails keep the molding in place. She'll join the pieces of glass using strips of lead called cane. Lead because it's soft enough to bend to the shape of the pieces. After straightening out a long strip of cane, she cuts the various lengths she needs to border each piece of glass. The cane is shaped in such a way that the glass on each side just slides right under. The cutting pliers, called nippers, are specially designed to slice through the cane without deforming it. Once the artist finishes assembling the glass pieces, she pushes everything gently against the wood frame. This squares the panel and ensures the pieces fit together snugly. Now she brushes on flux, a type of acid. This cleans the lead cane so that solder will adhere well. Using a soldering iron, she applies a bead of lead and tin solder wherever two strips of lead cane join. Then she uses a short bristled brush to coat the lead in black putty. This makes the seams watertight and gives the lead a darker, aged look. Finally, she sprinkles on calcium chloride powder called whiting. This sets the putty and polishes the glass and lead to a shine. After 4 painstaking hours, the panel is finished. More elaborate stained glass works feature hand-painted detailing. The artist first prepares a design on paper, then cuts the pieces of glass accordingly. He paints the design outline on the pieces in black, then fires them in a kiln to set the paint. To create shading, he applies a coat of brown paint called grisaille. Using a dry brush, he removes it from the parts he wants to highlight, then he fires the glass again. Now he paints in the final details and fires the glass for one last time. The paint contains powdered glass, so the intense heat of the kiln bonds it to the glass pieces. The result is nothing short of spectacular.
Fabric is made from thousands of braided threads. This mill has 700 bobbins of polyester. Each bobbin contains 250,000 meters of thread. We begin by separating the threads. This warp unit takes the 700 strands and assembles them. Then this comb separates them. Other strands are added, and in total, there will be 7,000 of them well aligned. One fabric is composed of threads braided at 90 degrees. The warp threads are assembled lengthwise, while the weft threads are joined transversely. To prevent the threads from tearing, they pass through a bin of glue. These rollers eliminate the surplus. The glue will be removed with water before dyeing the threads. The glued together threads exit this machine. These large green cylinders are heated and dry the glue on the threads. Knitting will soon begin. The 700 strands are newly separated on this loom roller. Each thread must pass through a blade to produce a specific design. This machine takes the 7,000 strands of thread one by one, and they pass through the blade. It's a highly precise operation. The threads pass through a blade, and the weaving finally begins. On this jacker-type loom roller, the warp thread is inserted by a jet of air. The weaving machine assembles two loom rollers made of 7,000 strands. The fabric reaches a width of 3.65 meters. The dark threads are inserted into the weave. They insert 600 weft strands per minute. The blades remove the weft strands to insert the warp ones between the two. A comb pushes the weft. The plate of the breakage chain stops the machine should a thread break. This bobbin contains 250,000 meters of thread. That's 250 kilometers. The weft thread is in the insertion nozzle. When a weft is inserted, an air jet nudges it in. The loom roller operates at full tilt. It makes 600 thread intersections a minute. Weaving is now over. We move on to the following steps: washing and dyeing. Washing is done in a soapy solution at 80 degrees in a continuous manner at a speed of 60 meters of fabric a minute. The fabric is rinsed in clear water of about 30 degrees. Now it's on to dyeing. This is done with jets. Up to 12,000 meters of fabric are placed in clean water into which colorants have been added. The solution is heated and the fabric soaks here for about 6 hours. Then it will be rinsed in lukewarm water. The fabric is placed in a bin. This machine is called an opener. It unfolds and stretches the material before rolling it up on an immense roller. And now the roll is almost full. We now move to thermosetting in a high-temperature oven which dries the fabric. The temperature is 200 degrees centigrade at the oven's entrance. The fabric circulates here for 45 seconds. This finished roll weighs 1,500 kilos. The bobbin that we saw at the beginning has produced 25 kilometers of fabric.
Lapel pins let you proudly show off where you've been or where you stand. From an event you've attended or your political beliefs to your professional affiliation or your favorite sports team. Lapel pins cost pennies to produce, but some are collector's items worth thousands of dollars. They may be tiny, but they're out there in huge numbers. This one company turns out about 5 million lapel pins a year. It all starts with a sketch of the pin design, and from that, the master, a negative made of magnesium, a type of metal. They'll make copies of this master to create a production mold. But first, using what's called a coping saw, they cut out the front and back pieces of the master. Using a dispenser about the size of a sewing needle, they glue the pieces together with epoxy. It takes 5 minutes to dry. Then they cast enough copies of the master to fill up a rubber disc. After tracing the outlines, a worker uses a surgical knife to meticulously carve out the cavities. He softens the rubber with paint thinner to enable precision cuts. Then he places a copy of the master in each cavity. Another disc goes on top. Then it's into a machine called a vulcanizer for 1 hour. This machine uses heat and pressure to cure the rubber, making it as hard as a car tire. It also melds the rubber around each master copy, embedding the detail. This will be the production mold for producing this pin design. Now, using a surgical knife again for precision, they carve out sprues, channels that during the casting process will direct the flow of molten metal to the cavities. They also make smaller, curved channels called runners to filter out any air or dirt particles. It's crucial to position the sprues and runners correctly because this mold produces an entire line of a particular pin. Mess up and they'd have to remake the mold from scratch. Next, they insert a centimeter-long brass tack called a post into each cavity. It'll later fasten to a clasp, attaching the pin to clothing. The post goes in now rather than later so that it will fuse to the back of the lapel pin during casting. Now to close the mold, they align the buttons on one half with the depressions in the other half. The mold then goes into what's called a spin casting machine. Using a cast iron ladle that can withstand the fiery temperature, they pour in molten metal, either pewter, zinc, or a tin alloy. As the machine spins, centrifugal force propels the metal into every nook and cranny of the cavities. After a minute of spinning, 400 rotations, the mold comes out. The metal takes about 5 minutes to cool and harden. The factory remelts the excess metal for the next batch. Next, a brass clasp called a clutch goes onto the post. Now the lapel pins go for an hour-long wash in soap and water and abrasive stones. The stones smooth out any rough edges. The pins go into the electroplating tank for a surface coating of metal. How many coats and the types of metal vary with the design. An electric current draws the metal particles onto the pins, plating them thoroughly. These pins first get copper plating, then nickel plating, then gold plating. Now it's time to paint the lapel pins. Workers follow a numerical guide like a paint-by-numbers kit. They paint each pin individually using minute quantities of epoxy paint. They control the paint syringe with a foot pedal. Once the paint dries, a machine called a pad printer gathers up ink and stamps on the tiny details, the ones too small to paint by hand. Pierce the post through the fabric, secure it with the clutch, and this lapel pin is now ready to wear.